Hi everyone, my name is Patrick Akil and welcome to this KodeKloud Live session. Joining me today is Saiyam Pathak and he's going to give us a little demo on how to deploy WebAssembly. And before we do that, he's going to share a little bit about what WebAssembly is, where it came from, and where we are right now. Hi Saiyam, how's it going?
Hi, Patrick. Thanks for having me. I haven't always been wanted to do something in collaboration with KodeKloud, and nothing better than the free week, which is happening, and the series of awesome streams. And excited to be part of it and explaining about WebAssembly.
Perfect. Let me tell you a little bit about Free Week before we get into the WebAssembly part, because this week and this week only, we have Free Week over at KodeKloud from the 25th until the 1st of October. So there's only a few days left. All our exclusive content is actually free of charge. So you have access to more than 65 premium courses, more than 500 hands-on labs, as well as KodeKloud Engineer 2.0, which is kind of a real-life project example. Here you'll have a little snippet. So on the left, you have multiple choice questions. This is what a hands-on lab would look like. On the right, your terminal. And to answer those questions, you'll actually have to do some hands-on terminal work to get the right answers in there. Let me share you a little bit about our learning paths. So one of my favorite things is we have role-based learning paths as well as domain-based learning paths. Roles, you might see some that are familiar: Kubernetes developer, platform engineer, or even DevOps engineer. For the domains, we have specific technologies, as well as some cloud environments here: Azure, GCP, AWS, it's all in there. And when you select one of the learning paths, it really depends on what your current skill level is. So whether you are really starting from scratch, whether you already know the basics, or you want to, for example, dive deep into infrastructure as code concepts, you can select the level that is where you are right now. And from there, we build up your knowledge as a baseline. So we really cultivate that knowledge, make sure that it's retained in a way as well, because that's the most important part. If you don't know where your current skill level is, we have a test for that as well, where we think you fit in right there. And one of my favorite features is right here. Depending on how much time you can spend per day, we can calculate how long the course material will take for you to complete it. So whether you can spend 2, 4, or 6 hours, doesn't. So head over to KodeKloud right now. There's only a few days left, and experience what it is premium access. Now, back to Siam. Go ahead, man. Feel free to share some slides and cover some WebAssembly stuff.
Awesome. I have some slides, fancy slides as always, and then there will be a live demo, and I hope that the demo works. WebAssembly. I'll be talking about what it is, why it is important, cutting up the hype. We'll go by the hype and we'll start to break it down into logical, practical stuff, and explaining why it is important, why you should care, why you should learn, and how you should be going about. And definitely, we'll keep the cloud native center in between. So we'll not deviate from the cloud native angle. And the demo that we'll be doing obviously will involve Rust, WebAssembly, and Kubernetes. So things will be exciting. But yeah, before that, definitely check out the KodeKloud free week. I think they have some amazing courses, and you should be enjoying those, definitely free of cost. And then when you go back uh, after watching this stream, I would like you to kind of tweet, post about your experience, your learning experience from this particular session, what you learned. Actually, you can tweet during the session as well. It's completely okay. But after the session, also, like, what you learned, and try to build something. Build something, and target it as WebAssembly, and then run it on one of the playgrounds in KodeKloud. So let's begin. As Patrick mentioned, my name is Saiyam Pathak, and I'm a field CTO at Sivo. So Sivo is a cloud service provider, and I am focused on building the next gen simplified Kubernetes service. I'm also CNCF ambassador. I'm author of two books, CKA scenarios and CKS scenarios. And there's a special coupon only for this stream to get 20% off, which is Learn Certs. So if you want, you can just go to the Gumroad and enter the Learn Certs coupon and get the 20% discount exclusive to the people who are watching it live. So that's why live is always fun, right? And keep sharing about the stream so that the numbers keep popping up on. I think it is streamed on multiple platforms, LinkedIn, YouTube. So just keep sharing so that more and more people can learn about WebAssembly and get involved in WebAssembly and the large ecosystem that it has become. Um, I'm the founder of Cube Simplify, Simplifying Cloud Native. So there's a YouTube channel that you can, do subscribe to if you like to learn more dope cloud native stuff. And then active on Twitter. So the coupon is Learn Certs. Just in case anybody wants to know, I'll type it down as well. Okay, moving ahead. WebAssembly. Now, when we talk about WebAssembly, the first generic question that comes to mind is basically what it is, and there are few things that immediately pop up into the head, like, is it replacing JavaScript, because we have heard so much? Is it something that replaces Docker, because we have listened or saw some of the tweets from the pioneers in the industry about WebAssembly and Docker, comparing it, what it is it a new Java? Because when I tell you the kind of one of the definition from one of the pioneers, you might relate this, and actually it's a very relevant comparison as well. So you might compare that with Java ecosystem, and then you have, is it a new programming language? So what exactly WebAssembly is? So going down the memory lane, I would like to read this definition by Luke, uh, and this is coming from 2015. So WebAssembly defines a portable, size, and load time efficient format and execution model specifically designed to serve as a compilation target for the web. Now, this very well defines and gives the context of WebAssembly. Like, it's a compilation target. What does that mean is, you have a code, you compile that code and you run it. So WebAssembly is a new type of compilation target that compiles to a new type of format, which is a universal bytecode that can run on any platform. Now, this is not something that WebAssembly was, out of the box innovation, uh, and there was no prior efforts. So there were prior efforts. If you have heard about Java applets or Adobe Flash or VB Script, they tried to do, the similar thing of running the applications inside of the browsers, but very specific to specific languages or specific applications or specific use cases with tight integration. WebAssembly is the learnings, obviously the learnings from the past, and the same target that people wanted to achieve when there was this Java ecosystem. Like, you should have a universal bytecode that runs everywhere, and all the languages should compile to a certain bytecode that you'll be able to run and execute on any platform. Now, what makes this interesting is that it's a joint effort by a very huge organization. It's a W3C standard. Now, this is gold. So after HTML, CSS, JavaScript, it's the fourth one to be marked as the W3C standard. And instead of focusing on a particular language, it focuses on a new binary format. Like, obviously it focuses on the native languages, but the more focus is on how the new binary format can be made in such a way that all the languages, all the compilers can get it to this particular level, and that can run. So definitely it's something to be compared with JVM, and that's a very good comparison. If that is coming to your mind, there's nothing wrong with it. But JVM, when we talk about native languages, so WebAssembly was for the native languages initially, like C++, Rust. Obviously, the ecosystem has grown, but JVM, obviously Java specific and other like Scala and all that can be compiled to the JVM bytecode. So that was there. Strict sandboxing. So when you think of WebAssembly is something very strict sandboxing with no access or information about anything, because it runs completely isolated. And third, there is no standard, like it's a W3C standard. It's meant to be implemented. The standards are meant to be implemented for all the languages. Let's try to see this. This is the kind of a timeline. So it's, again, it's not something that has never been done. So it all started back with, in the 2012 era with ASMJS. And then in 15 to 18, if you see the initial, after the initial announcement, and we saw the tweet as well of what WebAssembly is. So it was announced, and then what people wanted is, people wanted to run their web application, their application not only on the desktops but also on the web, because web was the most widely used thing. So people wanted their applications to be provided, widely consumed for the web. And that's where WebAssembly was getting more and more adoption. So you can see, all the supports which are there, more progress in the browser. 2000, and then the specifications. So I think in 2019, 18 and 19, the first 18, initially the first working draft was made. And then in 19 was a very, very cool year, because it was accepted as W3C standard. And then WASI first proposal was published, which is the WebAssembly system interface, which we'll be talking about later. If you do not understand the jargons as like right away, it's totally fine, because there'll be a lot of examples that I'll be talking about that will even clear all the stuff that I'm talking about right now. But just for now, understand that WebAssembly is a compilation target. Okay, and we'll compare it with different things. For JVM, we have already compared that it's not nascent to only Java. It is like for all the languages out there. It's a compile time target, and it has secure sandboxing, and we'll come to some of the other features as well. And then in 2021, you can see the first component model. We'll talk briefly about the component model as well. 2022, the core specification work for WASI Preview 2. And then in this year, more focus definitely is being to polish and publish the component model WASI Preview 2. And one of the latest use cases in WebAssembly ecosystem, you will be seeing on all the WebAssembly frameworks, runtimes, and organizations, is the machine learning inferencing using WebAssembly. So I think that kind of gives you a simple overview of how it is being picturized as a timeline. So it's not something that just popped up. It's been there, getting matured, getting polished, adding number of use cases, seeing number of success stories, and adding more and more on top of that. Moving on, let's talk about some of the success stories. So if you see this WebAssembly success in the browser, so most of you would have heard or worked on Adobe Photoshop. Like, it's one of the biggest photo tool that most widely used, obviously. So Adobe Photoshop, you can run now Adobe Photoshop in your browser. Like, it's a very heavy application, and you can run it with same smoothness in your browser only because of WebAssembly. Figma. So Figma is something, again, very widely used, and that is being powered by WebAssembly. Same smoothness, you are getting same flows, same smoothness, and that is only with the power of WebAssembly. So again, near native speeds is something that WebAssembly provides. Games, online gaming, a lot of online gaming is being powered by WebAssembly. Your Amazon Prime Video, Google Earth is powered by WebAssembly. And you can see the amount of traffic it receives. You can see the amount of so many, there are so many things and so many bits and pieces in WebAssembly, and getting that sort of domain. Like, we want to run Google Earth and some of their other applications. That is why I said the big pioneers are investing heavy in the WebAssembly ecosystem. So this is how it looks like. So if you didn't understand anything till now, it's fine. Let's start from this particular example. So if you see here, you have C, C++, Rust or Go, you have code over there. Now in the standard web application, you are having your HTML file, your CSS file, your JavaScript file, which is running fine on the web browser, completely okay. Now, what WebAssembly brings into this particular thing is you can write your own code in the language of your choice. Compile that. So because WebAssembly is a compilation target, compile that to a WebAssembly module. So here you are compiling that to the WebAssembly module. Earlier, the compilations were for limited languages. Most of the languages were not there. C++ and Rust, it started with that, but now over 25 languages natively are supporting WebAssembly as their compilation target. Go 1.21, if you have seen, it has native WebAssembly support. So you can use your same standard tooling and just change the compilation target and point it to WebAssembly, and just it will give you the artifact of .wasm file that you should be able to run anywhere on any system, irrespective. So it is truly platform agnostic. Yes, you have heard it before, because some of these promises were obviously made if you go back to the Java ecosystem, but I have already explained how it is different from Java. So the most important benefits definitely that WebAssembly brings to the table is secure sandboxing, and that is actually one of the core features that WebAssembly, the governance, and all the people who are who are governing it and who are forming the specifications, this thing is the top priority. Irrespective of what they are developing, how they are developing, secure sandboxing is something which they do not want to leave. And even if you access to the file, which we'll talk about in just a minute in the next set of slides, so the secure sandboxing is something that you have to have in mind when you're developing any new specification, proposal, or enhancement. Near native speeds, and that is again one of the huge powers. And you can see, Google Earth spin, you can see the online gaming, how fast it has to move here and there. So the near native speed has to be there, no lags, and running in the browser. So it's pretty cool. Polyglot, definitely, meaning writing in different languages of your choice, and language agnostic stuff. And smaller footprint, because it is independent of the OS, it is independent of the libraries, it is independent of any other information. It just has the code to be executed, so it naturally transforms into these smaller binaries. I can we can I mean, if you compare even with the Docker, we'll definitely do that. For a simple, very well managed image also, if it's coming out to be 19 MB, then your WebAssembly module for the same set of workload that you're running on that particular machine image will be less than, or approximately to 2 to 3 MBs, which is fairly low. Like, you can reload that 2 megabytes, pull that 2 megabytes again and again and do stuff, rather than the 19 MB. Although 19 MB is also pretty smaller in size, but still we are talking about edge cases. We are talking about running on edge, very small devices. So that's where it becomes, these things, smaller and smaller sizes becomes very important. So when you talk about running things on edge, WebAssembly has a lot of edge running on the edge. Moving on. Now we have seen WebAssembly success in the browser. So WebAssembly is successful, there's no doubt about it. So one hype that should be gone till now is WebAssembly used somewhere. So you have seen one of the top use cases. WebAssembly is definitely used in production heavily in the browsers, very successful. Okay, cool, done. WebAssembly is successful, I'm happy. But the thing is, whenever there's a technology that is being developed, so a technology develops and then people try to adopt, but the number of cases it extends, because there are people with different mindsets, different brains, and they see, oh, isolation and security, multi-platform, instantaneous startup time, smaller binaries. Wow, that's a perfect fit if I run it on the servers. That's a perfect fit for serverless application. That's a perfect fit for the applications in the cloud. So why it is only for the browser? So that's where everybody started to work on how we can make it work outside of the browsers, how we can power the server side WebAssembly. Is it only for the browsers? We should start thinking about WebAssembly on the server side. So this is where the evolution waves coming. So traditionally we were having servers, and then we had virtual machines virtualizing the servers, then we have containers virtualizing the operating system actually, and then we have WebAssembly that is only the smaller part and the smaller unit in that particular ecosystem, just running your functions which are needing. Why you should care? Now here comes very interesting part and interesting story. So you can see, so this is now just see the years. WebAssembly got adopted in 2019 to the W3C standards, and the WASI, this was after the WASI proposal, and I'll talk about what WebAssembly system interface is. So just after the WASI proposal was announced, Solomon Hykes, who is the founder of Docker, if anybody doesn't know. So Solomon Hykes was on the founding team, like he's a co-founder of Docker, uh, and he tweeted, like coming from the person who built Docker. Remember how Docker revolutionized everything, and remember that we are all here because of Docker, like KodeKloud having all those courses, Docker, microservices, Kubernetes, and whole ecosystem. CNCF, you can see the massive landscape because of Docker, Kubernetes, and the whole ecosystem. Now we are seeing what we are seeing on the screen is crazy, right? If Wasm and WASI existed in 2008, we wouldn't have needed to create a Docker. This is how important it is. WebAssembly on the server side is future of computing. A standardized system interface was missing link, and let's hope WASI is up to the task. This is coming from the person who actually created Docker, made it successful, and we had the whole ecosystem around Docker. Now I'll tell you how the minds and the brains of the people who have built successful stuff works. Now here in the next subsequent, so the story doesn't end here. So March again, the same day, it's like 2019. Just remember the year 2019. So will Wasm replace Docker? Obviously people would have asked that question to the person who created Docker. No, but imagine the future where Docker runs on Linux containers. Docker runs Linux containers, Windows containers, and WebAssembly containers side by side. And over the time, Wasm might become the most popular container runtime, and Docker will equally love it. Now here comes the fun and interesting part. Coming to November 2022, Docker announced its first support preview for WebAssembly. Now that's crazy, right? Because you can see that the power that people saw for WebAssembly and WASI, especially when WASI came into the picture. I'll definitely tell you what WASI is. Just hold on for one more minute. So when WASI is coming up, and it opens up whole lot of doors, whole lot of possibilities, and now Docker also worked in the same way and made it possible. And you can actually, we'll do it in today's demo. We'll definitely do it, and we'll run WebAssembly as a pod, which is obviously running a WebAssembly container inside a Kubernetes cluster. So that is possible. And this prediction was made in 2019, and this happened last year. So you can see uh, if how the visionaries have been talking about. So coming again to the hype, so that's not a hype anymore. It's actually happened. People worked through it, people saw the benefits of it, people saw improving it, number of application use cases, and that's why it moved on to the next stages. So let's take again another example. This is a Rust code. So this is what we'll actually be doing today. So we are a user, like you are a user, you write some code. It's a hello world Rust program, you write it. Then Cargo is a build tool. So like you use Cargo utility, a CLI, to build, and you just target it to Wasm32 WASI. Now this is important, Wasm32 WASI, and it will create a file called hello.wasm. And that's how it looks like. And this hello.wasm can run on any architecture, x64, x86, ARM, irrespective of anything, just it needs a WebAssembly runtime. Now comes the interesting part, like WASI. So the thing is, when we talk about running WebAssembly on the server side, so on the browsers, it's easy because on the browsers, there's no operating system, and you don't need to have access to the host operating system. You don't need to have access to the file system. You don't need to have access to the environment variables. But practically speaking, when you want to run application on the server side, you everything is files. you need to interact with files, you need to interact with the directories, you need to read a file, open a file. So basically anything apart from numbers, WebAssembly wasn't able to do anything. Coming to the file system space where it wants to interact with the host, and how do they do that? Because WebAssembly is running and is do not know which host you are running. You are running on a Mac machine, or you're running on a Linux, or you're running wherever with different set of operating system libraries, dependencies, different folders, bin, etc. So it doesn't know. How do we make an interface that can talk to the host operating system and then bring back the, because I don't want to leave as a secure sandbox. So I am a WebAssembly module. I don't want to leave my space, but I want to interact with the host. I want to interact with the host. I want to pick one file. I want to read one file. I want to write to one file. So I want all these small pickiness over there. I want to write logs to one file. So like console.log, I want to access one file. I want to read some of the environment variables and all these use. I want socket connection, threading, and all those things. Although they are still in works, I'll definitely talk about that as well. But the the small picking of these was made possible using WebAssembly system interface. So that is why it is so important, and that is why WASI made it possible to have interaction with the operating system and making sure that it opens up a use cases for running WebAssembly on the server side, so you can actually have practical use cases over there. So you have WASI, and so it's a system interface. Obviously there are multiple implementations of WebAssembly system interfaces. So you have interface, then you get implementations of that interface. And Wasm time, Wasm edge, all these are the runtimes which helps you to interact with the operating system, and that has implemented the WebAssembly system interface. So that's where your WebAssembly module will talk to the, like the WebAssembly runtime will be able to run the WebAssembly module, and using the WASI interface it will be able to talk to the host operating system and get the stuff that you need for your application. As simple as that. So yeah, as you can see, application make talks to this file tree which is there via the kernel, which is called the sys calls. So all these are the system calls. So all these are the sys calls, and these are now done using the WASI, and making Wasm use outside of the browser. And again, anything that comes in the Wasm ecosystem has two things: top priority, which is security and portability. That's why I have written in every slide as well. So you have security and portability over there. Component model is something that you might have seen if you have seen the curve carefully, the timeline. So component model is something, let's say you have written a component, and that's a very interesting component I want to use. So component model makes it possible to let you use something in your code written by someone else. So kind of a libraries that you import. So multi-language library import will be possible using the component model. It's in the final stages. So last it was talked about, I mean it's still talked about every week, but last I heard was at the WasmCon, which just happened last month. Oh sorry, this month, yeah, which just happened this month. So in the WasmCon, it was a very interesting discussion on WASI preview 2 plus the component model, which are almost ready to be published. And then the whole game again changes, because it powers, or it encourages the reusability, language neutral plugins. So you can create a number of plugins, and definitely it's governed by the bytecode alliance. So you can refer or think of bytecode alliance as the alliance or the foundation for WebAssembly, similar to what CNCF is for the cloud native ecosystem. Now switching the gears, coming to our angle of WebAssembly and Docker, and understanding one of the most obviously most asked questions, like what happens now? Is container dead, or we are still using? See, nothing ever becomes dead just like that. Monolithics are still there, mainframes are still there, everything is still there, even with virtual machines and all these things. Even when you have containers and Kubernetes, virtual machines are there. And that is why there are projects like KubeVirt that lets you run virtual machines inside your Kubernetes clusters. So nothing will go away, that is for sure. But it opens up new set of possibilities, and you will redesign, or let's say this way, So now when the WebAssembly, with the WebAssembly knowledge and the maturity, you will be writing your microservices and the application in a new way. So that's the thing that changes. And then you deploying it in using the same tooling, because I'll tell you how you can use the same tooling. So one is this. Another thing is, you can definitely try, because of all the tweets and everything, people want to compare WebAssembly with Docker. So let's do it quickly. So you have you have infrastructure, you have host operating system. On one side you have Docker engine, on the other side you have WebAssembly runtime with WebAssembly system interface. On the other side you have the container, which virtualizes the OS. So when you SSH or when you bash inside a container, you can do ls, and it gives you the same slash, the bin lib, all the directory structure which is there depending on which container you're using. But it does have the operating system library and dependencies, whereas WebAssembly just has simply the code that is to be run, that's all. So it's not dependent on, it doesn't have the libraries dependencies, because it doesn't know about the operating system. So it just abstracts away the operating system, as that it doesn't know about the operating system, it doesn't know about the host OS, it doesn't know about where it is running it. That's why it is platform agnostic. Many people think that when you create a Docker image you can run anywhere. No, you have to actually build Docker image specifically for each platforms. You can't simply run a Docker image built on an ARM platform on a Linux system. You have to build it. Many people didn't know that before things started to get errored out. So that's the thing. So it is true, write once, run anywhere. Although, in my opinion, that's not the true power of WebAssembly. I think the true power of WebAssembly is the speed, size, and the startup times, because that is where it opens up the door, specifically for the use cases like serverless, where your cold startup times have been the main issue. So I think the next gen of serverless is definitely going to be powered by WebAssembly. It is happening. You take any organization out there, Wasmer, or you take the second state, or you take fly.io, I think that also has some sort of, then you have this Fermion, and then all these are are having their serverless platforms, and they are powered by WebAssembly, because makes very much, it's so much sense to have WebAssembly powering this, because of instantaneous startup time. And when we talk about instantaneous startup time, think of like you are clicking an add button on a website, and there is a database being populated by 1, 2, 3, 4, and that's how quick it is. Like, you click it, you keep clicking it, and that's how fast every time a WebAssembly module will instantiate, add it to the database and kill off, add it to the database and kill off. It's that fast, that instantaneous, that you won't even know. So after this, you can see speed obviously is fast, portability is obviously better. When we talk about the WebAssembly module, size is obviously less with respect to the Docker image that gets built. It's a W3C standard. Startup times are pretty good. System interaction, and also the security. So security, Docker containers are not secured by default, uh, but WebAssembly modules definitely are. Like, they are run in the hard sandbox environment. Very difficult to break into the WebAssembly module. Interesting. Time goes by so quickly when you have so much to talk on. So now let's not talk about the versus thing, because the thing is, with the existing tooling, with the existing ecosystem, with the existing developer experience, things go hand in hand. So let's talk about not WebAssembly versus Docker, but WebAssembly and Docker, because that is much more sensible, and Docker containers are here to stay. But the thing is there a way that we can experiment or run our new set of or build our new set of applications, and have targeted as WebAssembly, and use the same tooling, same ecosystem that we have learned from the past decade about Docker and Kubernetes, and then run it? Yes, it's possible, and that was made possible using a thing called Run WASI. So to give you a brief on how the container D, or the system actually works, is first the request goes to Docker engine. So Docker doesn't run the container. Then it goes to the container D. Container D is a high level construct over there. It's a long running process which is there. And container D also does not run the container. It is responsible for the life cycle of the container. It doesn't start the container. Then it goes to container D. Then it goes to passes the request on to run C. So if you see on the right hand side, it passes the request onto the run C. Run C is actually which starts and stop the container. So that's where I think we have the shims in the place. So the container D shim that just passes on the request and then takes back to the container D about the status of whatever that is. It started and completed its job and all that stuff. That particular layer, with the help of shim v2, you can replace that with the run WASI shim. And with run WASI shim, you are able to bring most of the WebAssembly runtimes like Spain, Wasm time, Wasm edge, and Warmer, and all those runtimes which are there. So I think that is something which is pretty interesting, because now you, with this architecture, you are able to run WebAssembly as containers. Again, in a simplified diagram, this is a diagram from the Docker team itself. So you have a CLI. So you say get image. So this, first it gets image from the registry, and then it creates the container, and then the request keeps on going until after the shim it reaches the wasm runtime, and then it comes back with the container ID, and then task ID. It attaches the container, wait the container to exit and run. Coming to WebAssembly and Kubernetes, very simple. With so how the Kubernetes ecosystem works, it's almost the same. You just have more layer of abstractions over there. You have more set of components over there. But in the end, obviously, your application is run as containers, and containers like the pods and encapsulate the containers. You can have single or multiple pods in a single pod. Sorry, single or multiple containers inside a single pod, and then kubelet is responsible for running the pod. And inside that, it's the same architecture. So you have container D as the CRI, container runtime interface, and CRI is responsible for running it and attaching all the other stuff as well. You have CNI, CSI, all those things. But in the end, if you have the WebAssembly runtime, if you have the container d.conf toml file edited with respect to the WebAssembly, which I'll just talk what all things I'm talking about if you don't understand. But the shim, so you have to understand one thing. The shim made it possible to run WebAssembly workloads on Docker and Kubernetes. So first was WebAssembly in the browsers. With WASI coming in, it is able to run on the servers. With containerd shims, or the run WASI shims, it is now possible to run it on Docker and Kubernetes. So I hope you got the gist over here. Coming to Spin. So Spin is an open source project that lets you, so it's basically a toolkit or a framework that lets you create your application, a skeleton application in different languages and runtimes, and you will be able to run it, build it, and deploy it. So that's what needs to be done when we talk about WebAssembly on Kubernetes. So in Kubernetes, you have a node, you have a control plane node, and then you have set of worker nodes. In the control plane node, you have certain components, and then in the worker node, you have set of components. One of the components is container D. So what you have to do is you have to have container D shims placed in specific directories, and then you have to edit the container d.toml file. So you have to have the runtime, shims, and the container d.toml file edited, and then restart container D. Now, based on which Kubernetes distribution you're using, the editing of the container.toml file will be different. So one is for K3s, another one is for K8s in this particular scenario. Now you can do it on your own, but obviously the community, again, I say this, it's not the hype, because community has taken deep interests in building all these tooling so that you can run all these workloads. And there's another tool that is being built, that is already built, which is called Kwasm. So Kwasm is then operator to all the previous steps to be done in an automated way. So whatever I just said, you have to get the libraries and dependencies for the WebAssembly runtime, and then you have to have all the shims in place in the right set of directories, and then you have to have the node installers, edit the containerd.toml file, restart the containerd, and make sure everything is working fine. That can be done easily using the node Wasm node installer, and it works with almost any Kubernetes installer. Actually, even it should work with your KodeKloud playgrounds as well. So you should be able to run your WebAssembly workloads in this particular way also. So I hope till now, because now is the demo time. So I hope till now you understood what WebAssembly is without the hype, what actually WebAssembly is, how it is different in the browsers, its success in the browsers, how it came into the server side of things with WASI, how it came into the Docker ecosystem, how it came into the Kubernetes ecosystem, and how we are able to run it inside Kubernetes. And now we'll try to connect all the things that we learned, build something, and then deploy it onto a Kubernetes cluster. So let's go terminal mode now. And let me share the screen. So I hope you are able to see my terminal screen now, and the font should be fine. Before that, let me also share with you the gist, so that if you want to try this, so I'll put that in the private chat so that um, people, the KodeKloud team, can share the link with everyone of you. So this is the repository. I mean, you're not able to see the repository, but once they share the link, so that repository is having all the steps to do whatever I have done over here. So first step that is being done is installation of Spin. So I already have Spin. So if you see Spin is a CLI that is used to create, scaffold a new application, and we'll use Spin. So I already have Spin, but you can install it. So what we'll do is, you can see there's nothing right now in this particular folder. So what we'll do is Spin new, and it gives me plenty of options. So it gives, like, you have C, empty, Go, JS, PHP, Python, Rust, yeah, PHP as well. And don't get stopped. So Rust, Zig, TypeScript, and all these. So we'll take a simple HTTP Rust. We'll give it a name, Code Cloud. Enter, you can enter description and base and path. So it actually created KodeKloud, and it created a cargo.toml file, because that's what is required in Rust. It created a spin.toml file where you can specify some of the complex use cases of dependencies and stuff, and what all components you want to include. So for now, we just are including the source, target, KodeKloud Wasm, and when we do, basically it says when you do a build, what command to run. So it's similar to building using cargo, build, target, release. The one that I showed you in the slides, in one of the slides, it is doing the same thing. But you don't have to write this command. You can use the abstraction layer. So it's making your life more and more easy, right? So now what we'll do is we will edit, definitely try to edit something in the source lib, and we'll say hello, or maybe we'll say get your KodeKloud subscription now, and let's save it. And now what we can do is we can do spin build. So in behind the scenes, it is doing a cargo build, the command which was there in the spin.toml file. So you'll be able to see that. So if you want to actually see, you can see ls target wasm WASI 32 folder, sorry, and release, and you can see KodeKloud.wasm file. So you can see the wasm file got created. Now the next thing to do is definitely install kwasm. So first you need to have a Kubernetes cluster. I already have a Kubernetes cluster, but you can use the KodeKloud playground as well. So kubectl get nodes, So that's a Kubernetes cluster. kubectl get pods. So you can see I don't have like this is a job, okay, but I don't have the Wasm operator already installed. So what we'll do is we'll actually delete the Wasm namespace so that it's from the scratch. And now what we are going to do is we will create, yeah, we need to install Wasm. So for that, you need to have this command, helm repo add. It's a very simple helm installation. I definitely already had, so it will say that I already have this configuration, which is fine. And now I'll try to do a helm install for the Wasm operator. Again, the same command, like same command in the sense, the one that I ran sometime back, but for you it's new command for helm, but just using the same convention of helm, creating a new namespace of Wasm and then installing Wasm operator. So you can see Wasm is installed. I can see get pods -net Wasm, and you can see it's running. And I told you it will help me in annotating. Oh, sorry, it will help me in configuring my node. Listen carefully. Wasm is helping me in configuring my node in order to run my WebAssembly workloads. So that's what it is doing. So kubectl get nodes. Now how it works, let's see. Kubectl get nodes. We'll take one of the nodes, let's say NOSV3, and we'll annotate it. So kubectl annotate node this with kwasm.sh kwasm node equal true. So the node is annotated, and we'll see one job to start and run. So we'll see this Wasm job is getting created because it is getting created to configure that particular node to run WebAssembly workload. So it is doing all the configurations and all the stuff which is happening. So soon should be done, hopefully. And it's completed. You can see that it is completed. So our node, which node was that? So our node NOSV3. So okay. So NOSV3 node is now configured to run your WebAssembly workloads. Okay. Now let's try to have this. Now what we'll do is we'll create a Docker file. Because in order to run a workload inside a Kubernetes cluster, you need to create a container, but we haven't created a container OCI artifact out of the WebAssembly module that we just created. So let's create it. So vi Docker file, add it. In this, edit the .wasm file. I think our name was KodeKloud, if I'm not wrong. KodeKloud. Hopefully, there should not be typos. Else things won't work. We'll fix. And now we have to build this particular image. So what we'll do in order to build is v1. So we'll use Docker buildx platform, and here we'll specify the WASI Wasm platform, and then we'll tag it as Saiyam 911 KodeKloud v1 and build it. So it's already built. Now we'll push it. Docker push. It's pushing to my registry. You have to push to your registry. Else it will ask you credentials for my registry, which you don't have. And now we'll create a runtime class, because that is something we have to create. So we'll create a Wasm time runtime class with the handler spin, and that is where it will know not to use runc and to use Wasm time spin. Now is the time to create the deployment file. So let's do that. Deploy.yaml, and It's a simple deployment, KodeKloud Wasm, and we specify the runtime class over there. And we also need to specify one more thing, which is the node name. Let's save it first. Which node? Let me see which node it was part of. kubectl get pods -a. We can just see 3 minutes ago. Yeah, this is the node NOSV3. Okay. kubectl get nodes and NOSV3. So we'll copy the node name. So basically, node name bypasses the scheduler and it directly schedule that onto the node. You can use node selector and put some labels and try to use it as well. For this particular demo, I'm just using the node name over here. And you can see the node name is there. And the name of our image was KodeKloud V1. And now we'll do kubectl apply -f deploy. kubectl get pods. You can see a container is creating. It's running, which is good. And now what we'll do is kubectl port forward deploy KodeKloud on the port. Let me see. kubectl gets deploy. We named it Wasm or something. Yeah, KodeKloud Wasm. Wasm and localhost 80 should give me results. And you can see, I hope you can see the curl command that I just did. So it's get your KodeKloud subscription now. So each time I'm doing this, it's actually instantiating that Wasm module and giving you the output. Now let me just come back to the screen. Okay, you are not able to see that screen, or you are able to see that screen. Let me try to reshare the current window. Okay, now you should be able to see it. Can you add my terminal to the stream? Yeah. So basically, I'm doing a bunch of curl requests. It's same as in the browser. So you can see. Okay. And that's exactly what we wrote. So basically what we did was, so the demo is complete. Now I'll explain you. So basically what we did was we created a simple Rust hello world HTTP application from scratch using Spin. And then we wrote a Docker file to have that spin.toml and Docker file. And then we used Docker capabilities and used the Docker command to build the application, which is the Docker buildx command, which was there. Docker buildx build and giving the platform. That's what make it possible to create an OCI artifact that has WebAssembly module. And then we created a standard Kubernetes deployment that you can learn from KodeKloud. So you can have a standard Kubernetes deployment that you can deploy onto the Kubernetes cluster. But if that deployment is on the node where you haven't configured the WebAssembly runtime container.toml file, it won't work. And if you have configured using kwasm or manually, then and target it to that specific node, then it will run absolutely fine. So you can have your uh, Wasm Edge, Wasm Time, Spin, Slide, at all these runtimes depending on your choice, or C run to run Wasm Edge. There are multiple examples that you can use. In this way, you have your same Kubernetes cluster with some nodes marked as WebAssembly nodes, where you can target your WebAssembly workloads, and some nodes targeted as Linux nodes, where you can run your Linux workloads. And hear me out, with the latest 0.9.0 release for the containerd Wasm shims, you actually can run a WebAssembly container and a Linux container inside the same pod. I hope you heard me right. So you can run the WebAssembly container and the and the Linux container inside the same pod. That is possible using the latest shim release, and using the latest KWasm operator as well. I think that is there. And we have a new KWasm logo. We distributed some of that stickers at CO Navigate, and some of our friends did it at WasmCon as well. I'll be there at KubeCon. If you happen to be there, definitely connect with me. I can happily give you some KWasm stickers. So I hope from this particular session, so the main motive was to explain, to demystify the hype with respect to WebAssembly. I hope you understood what WebAssembly is. WebAssembly on the server side, WebAssembly with respect to cloud native. By the way, definitely, just a few days back, a couple of weeks back at WasmCon, the cloud native Wasm landscape was launched. The cloud native Wasm landscape, it's more than a $57 billion industry, so it's no joke. It is definitely there to thrive. There are amazing companies like Cosmonic, Fermion, Dilypso, Second State, Wasmer, and many more. And the Dilypso one is more specific towards the observability side. Some of them are oriented towards the platform side. Wasmer has WASI X, which can run POSIX, Bash, all those things as your runtimes as well. So I think crazy things are happening in the WebAssembly ecosystem. Uh, Definitely follow me if you want to keep up to date, and definitely follow the cloud native landscape for the WebAssembly ecosystem, so that you know where the community is happening. Going, there is a WebAssembly working group in CNCF. Make sure to join that. There is a Run WASI working group. There's a KWasm channel, all on CNCF Slack channels. So if you are there, you can join those, be part of it, and be part of you can also be part of the compiler team working in the WebAssembly ecosystem. You can be part of at the end users building application and feature requests, or building some stuff. You can be part of the run times, where Wasm Edge, Wasmer, and Wasm Time, and contribute over there in order to enhance the capabilities over there. And there are endless possibilities in the WebAssembly ecosystem. So I hope you got all these things cleared, and you can kick tires with WebAssembly and start building something.
Awesome session, Saiyam. Well done. If you have any questions, we're going to get into our Q&A part of the session now. Feel free to drop them on LinkedIn or on YouTube. And to start off, you mentioned running WebAssembly loads and non-WebAssembly loads in the same pod. What is the use case there? Why would I want that in the first place?
Yeah, I think that it actually opens a lot of use cases. One of them can be if you have your WebAssembly module, and that wants a persistent layer. So that can be running the persistent layer, because WebAssembly modules is run till like it executes and it switches off, because it's just think of it as a serverless function that you're running.
Yeah.
And then you will be having your persistent one, which is there inside the pod, which is always running, and you can fetch, store locally, because they can connect and communicate on local host. So everything can be done via the local host. So I think it opens up a lot of possibilities. And one of the use cases where I always say that containers and WebAssembly modules run very good, because database application, you should long running processes or long running application, you can run as containers, and very short lived processes you can run as your Wasm modules, or Wasm components, I should say, with the maturity of the components in the ecosystem.
Exactly. So you can really leverage kind of the short lifespan of WebAssembly together with long-running operations in the same pod. Awesome. I saw you were using Rust, and obviously WebAssembly supports Go. I love using Go, and it supports different programming languages as well. does the programming language you use still impact stuff like the cold startup time or the footprint, or is it kind of generalized and is it all kind of fine grained in that way?
I think there are a lot of benchmarks. I don't have it handy right now, but there are a lot of benchmarks with respect to the programming languages, native speeds when you run it as standard programs, as containers, and as WebAssembly modules to
Yeah.
understand how things are working, how the cold startup times are working, and the performance as well. So I think that is something people can look into.
Yeah. So it does matter at the end of the day which programming language, but still, by virtue of running it within WebAssembly, you get all the benefits of that environment.
Yeah, definitely. It's same, right? You when you talk about the more native languages like C++ and Rust, they have certain set of advantages with respect to performance and speed. When you talk about Go and Python, they have certain set of advantages over the simplicity of creating and building stuff. So there are some here and there, and then the love of languages with respect to people, which is there.
Yeah, exactly. Question from my side. A lot of cloud providers are now making it very easy to run your applications, right? Just by going serverless. You have a cloud run on Google, for example. AWS and Microsoft have their own versions. Do you think they're going to transition and in the background it's also going to run in WebAssembly just for that kind of compute efficiency and those benefits there?
100%.
Yeah, right.
100%. 100%. Serverless, no question that the next gen serverless is powered by WebAssembly.
Mm,
So the new player, I would not say the new players, the existing WebAssembly players, and you can see their funding caps as well, like it's massive. So that's only because they see the value proposition. And the main issue with the serverless is the cold startup times. When you eliminate that, I think you can use it for even more number of use cases over there. And
yeah,
all these organizations, Fermion, Second State, they have their and the Wasmer one is serverless at edge, because at edge WebAssembly makes a lot of sense because of its very small binary size and the smaller runtime, because Warmer is very small in runtime perspective as well. So very small devices. I'm not talking about the Raspberry Pis, even smaller than those chips where you cannot run Kubernetes cluster, even if it's K3s. Yes, you cannot run K3s everywhere. It still requires around 50, 60. Like it's a 50, 60 MB binary, and you still require, around, I can't comment, but some good level of memory to execute that particular cluster and run your workloads, which are also not in KBs or in certain MBs, like very small single digit MBs. The machine learning inferencing, where you can have your and Michael Yuan, who's the co-founder of Second State, just tweeted a couple of days back on how cool is running ML inferencing without any PyTorch dependencies, Python dependencies in a WebAssembly module that is only 3 MBs. So I
that's
think
insane.
that is insane. Yeah. So it opens up use cases. There are, like, obviously I have been talking all the pros. The con sides of thing is the network sockets, the multi-threading,
Mm,
all the file operations, because it is getting done via the WASI interface. So the WASI preview 2 helps in some sort of things, but still the threadings, multi-threads, and all those things are still not rectified. But again, there are other things like WASI X, which is by Wasmer. Again, it's not as a standard which is there, but it exists, that helps you run your POSIX, your all sorts of that application, POSIX sort application directly in WebAssembly. So if you want immediate, you can try that. If you want to wait for WASI preview 2 for certain socket enhancements, network IO operations, so you can go for WASI preview 2. There are KV store type of use cases which Fermion is catering to, so I think it's worth reading that as well. It's like many things have SQLite inside of WebAssembly. A lot of things is happening, interesting things. People are experimenting with databases as well, how to improve efficiency and stuff. I haven't touched that part, but a lot of things in this space are like rapidly growing. So it's in the early stages of Docker, and it's at a this. So this is a curve, and it's at this point, and after this, it's a rocket adoption of WebAssembly across different ecosystems.
yeah, yeah, I love that. I always heard years back WebAssembly is coming, but then it was always from that front end point of view, right? And then I would always imagine, okay, when do you really need those heavy workloads on the front end? You give some great examples, but there's only one Photoshop, one Figma. There's only a few games, obviously, in the web browser. But running those workloads on the back end is what we already do. And that's a lot of optimizations to be had, which is awesome.
Yep.
Yeah. Cool. Then we're going to round it off here. Thank you so much, Saiyam, for coming on, sharing what you know about WebAssembly and really exciting us for the future ahead. If you're still listening, feel free to drop a like on LinkedIn or on YouTube or on Twitter. Subscribe to our YouTube channel for more WebAssembly content. And thank you for listening. Head over to KodeKloud and enjoy free week for the last few days that it's live. And we'll see you on the next one. Thanks for listening.
Thank you. Bye.
Yeah.